All right, so today I have my friend Daniel Lenton, CEO at Ivy, which you can find at the website unify.ai. Their tagline is, with one line of code, accelerate your AI development and deployment. And quick announcement, Daniel and Ivy will be at the AI conference in San Francisco, which is in person, September 26 to 27. So you can talk to Daniel there, see Ivy in person, demos and whatnot. And you can find more details at aiconference.com. And if you go to the episode notes for this episode, I'll stick a discount code. And full disclosure, I am an advisor to Ivy. And Daniel, with that long-winded introduction, welcome to the Data Exchange podcast.
Really, really great to be here, and great to have you as an advisor as well.
All right. So, like I said, so their tagline is accelerate your AI development and deployment with one line of code. But I'll do this in reverse. I'll start with deployment.
Yeah.
So I like to start, Daniel, with a problem statement. So what do you think are the key challenges facing AI teams on the deployment side?
Well, I think there's a few things. I think, first of all, just to set the parameters, basically deployment teams typically care about, let's say, accuracy, cost, and latency, and you have like relative importance for these different configurations. Maybe sometimes you're limited by the domain, you need to run on the edge, and therefore you become memory bound, for example. There's also GPU shortages as well. So that's another problem where sometimes you just need to get your stuff to run at all, and that's very hard to do with, without being able to get access to the certain hardware. So there's a few things to say. The most important, I think, being able to run your code flexibly across hardware is one big thing here, because with such shortages, you can guarantee that you can get an efficient solution, even with long tail end hardware that might not be possible so easily, off the shelf. So I think that's one. But I also think getting things running cheaply and efficiently is also very challenging. And it's not obvious with this huge AI stack when it comes to all of the compiler infrastructure and all of the hardware targets, what the best solution is. And we're trying to make that more transparent and easy for you to understand, so you can see all the options that are out there and choose the best configuration for you. So, yeah.
So for our listeners, a lot of what we're going to talk about here applies to all of machine learning, but I think it's fair to say our focus will be on deep learning, which is what's really taken over ML. So, Daniel, are there any specific problems that come with foundation models and generative AI now that we're talking about models that are much larger than we've had in the past?
I think there's lots of challenges. First of all, it's not always easy to fit all of these onto a single device. We're talking about potentially hundreds of gigabytes of weight parameters. So even to do inference, sometimes you end up doing sharding of the model, and you can do model parallel approaches, data parallel approaches. None of these are trivial and out the box. So just their sheer size is a big problem. And we're looking to basically, make that easier to also parallelize across different devices. But it also becomes a big problem when you're looking to run on the edge, because there's a lot of applications where people run ML models on the phone, for example. And when you have these massive models, knowing how to go from these, several billion parameter models to something that approximates them on a phone is very challenging. And you end up doing a combination of model distillation, pruning, quantization, etc. And this is also a big challenge, and something that we're working on as well.
So given these problems around cost, efficiency, latency, flexibility, what are most teams doing today, and why are they struggling?
I think most teams are, well, I guess they're quite confused. There's a lot of stuff out there. Obviously, what you can do is try to offload this and not wrestle with it and just use GPT-4 or something. Of course, what you then sacrifice is control. You get this very non-technically demanding solution to get things going quickly. You can use GPT-4, use LangChain, use some vector databases and get going. But if you care about really minimizing your cost, having full data ownership, you want to go with an open source model, And then you can use it off the shelf. One of the problems is that, I mean, PyTorch is amazing. There is PyTorch Inductor. There are strong deployment backends implemented there as well. But to get things running really, really efficiently, PyTorch is still not great. There's many cases where if you implemented the model in JAX instead, for example, you would get much better runtime performance. In fact, Hugging Face recently re-implemented Whisper in JAX, and they say they got a 70 times speed up for various reasons. That's because of more intelligent batching. It's because of, well, TPUs rather than GPUs. It's because of JAX XLA compiler as well. So I think what they're doing today is taking what's out there, taking these open source models, using them, but then paying, more than they need to be to get them running efficiently. And this is where I think we can help, because without needing to re-implement anything from scratch in a new framework, with one line of code, you can instantly get things running more efficiently with the exact same model without needing to worry about what JAX is, what XLA is. You don't need to know. You just have your PyTorch model, and we can make it faster. So I think, yeah, this is it.
Actually, I guess very quickly for our data scientists or ML researchers who are mostly concerned with building models, who don't actually think about deployment that much. So you've in your answer there, you mentioned a few things that some people may not be aware of. So I guess the naive conception of most people is, I train the model, it's okay. So this is the model, literally,
Yeah.
this is the model I deploy, right? So,
Yeah.
but what you're
Yeah.
saying is that's there's some steps that people do before they actually take that model that the research team built and before
Yeah.
they deploy. Yeah.
Exactly. And it's not to say that everybody is just taking a PyTorch model, they're deploying their Python environment and doing torch.compile. There is a torch XLA bindings, there are torch TensorRT bindings. You can export it to Onyx, and you can then deploy your Onyx model. There's now Torch Mobile. So there are ways that you can take this trained model and then do some kind of graph lowering or export it into more deployment friendly configurations. But still, it doesn't connect to everything that's out there. You can't instantly convert PyTorch to GGML, for example, this really efficient C++ implementations of a lot of popular models that can run on edge devices and so on. So in our view, there's so much. Yeah, exactly. So some people do just deploy the model they've trained, and that's it. And that's the quickest way of doing it. Other people do, of course, leverage the tools that are out there today and exist. But we make those, we create even stronger connections to other state-of-the-art technology and bring even more solutions to the table, which end up getting better results, basically.
All right. So then what are some of the key benefits of using Ivy for the deployment?
For deployment, I guess the two main benefits, firstly, would be that we are positioning ourselves not to try to own the entire stack. We're not saying that we are going to build the best compiler infrastructure from the ground up and it's going to be better than anything else out there. We're saying there's a lot of amazing stuff. There's OpenAI Triton, which is really, really good. There's Mojo language coming out from Modular soon, really promising. Obviously, the LLVM MLIR stack. There's XLA. There's Onyx. They all do slightly different things. There's Apache TVM. All of these have their strengths and weaknesses. And we're saying that let's genuinely build the glue that connects these things together in an elegant way that brings all of the frameworks. And that also does include long tail frameworks like scikit-learn pandas, etc., and NumPy. Bring all these frameworks together, all of these compiler infrastructures together, and just make them compatible. And we'll be the glue that holds that together. And therefore, of course, you end up getting better solutions for your unique use case, which is for your model, your evaluation metrics. And we can bring everything to you and get you the best solution. So basically, saving cost, running things more efficiently is the top benefit. The other benefit is just longevity of the code. So if you write your code in Ivy, which you don't need to do, by the way, this can apply out the box to a PyTorch model, to a TensorFlow model, etc., with one line of code. But if you write your model in Ivy originally, then you're developing directly in our IR that brings these benefits. So you actually end up with things being a little bit faster than if you transpiled the PyTorch model. If you write it in Ivy, you can take a few more shortcuts that are closer to our optimal deployment engines. And also you support all future frameworks. So now you can run this model and retrain it in a PyTorch project, in a TensorFlow project, in a JAX project. So effectively your model is elevated above the specifics of the frameworks and the infrastructure. It's almost this purely mathematical concept that's not bound to any particular stack and is, interoperable with all of them. So I think this is another benefit, the longevity of the code.
So Ivy is actually being used by teams for deployment, right? So
Yeah.
with that said, Daniel, can you describe kind of the typical workflow? Like, do people basically just do their thing, train their model, do all of the things they need to do to develop the model, and then what's the API or what's the UI for actually bringing IV into the deployment?
So it really depends. We try to make Ivy as flexible as possible, which means that your entire project can be built in Ivy. You can write your model in Ivy, you can write your data loader in Ivy, your trainer, all of this can be done in an entire Ivy project. And there's some teams taking this approach. It can also be a one-line deployment engine. So you have you train it in PyTorch Lightning, let's say you use, models from Hugging Face, and now you want to deploy them. And then it's just a one-line code auto-tuning sweep where we look at all of the clouds, infrastructure, compile infrastructure and frameworks and bring the best one and show you what it is, and then we can do that conversion automatically to that representation for you to then go and run, in your own Docker container, in your own cloud. We don't want to try to own the entire stack and just be a black box API. We're working on our own orchestration layer where we abstract the cloud, using Terraform, etc. And we run the Kubernetes and the auto scaling. But really, it can basically be what you want it to be. It can be one line in your otherwise large project. It can be an entire project, etc. We can manage the cloud. You can manage the cloud. We're really trying to be flexible. One thing I would say, which touches on to a new area as well, is that we're focused on deployment, but of course, Ivy also enables you to develop more flexibly across the boundaries of these frameworks. So you can also, at training time, take in other models, other libraries, etc. as well. So it's a pretty broad tool, and it can be used in all kinds of different ways. But certainly, let's say the tip of our spear in terms of where we're penetrating with most interest and where we're getting, a universal message that resonates with everybody, because not everybody needs to develop across the boundaries of these frameworks. Obviously, PyTorch is incredibly popular. What is resonating universally is make these models faster and show me what all these configurations would look like in this messy, complicated space. And let me just choose the best and bring cost savings. And it's as simple as that for those people. It's one line of code, and then they get the binary back, and that's it.
So do people, so Daniel, so are there knobs? So do people specify? So for example, here's my model. I'm going to deploy it. I don't know, CPU. I'm going to use CPUs, right? So, and then I want this amount of latency and so on and so forth. So what are some of the knobs that people can turn?
Sure, exactly. Well, I should also say that this fully fledged deployment solution is a work in progress. So, this is in relatively early development, but we're planning on this coming out in the coming weeks. And basically, the knobs will be, so there is a custom cost function that people can specify, which weights latency, cost, and accuracy. And these things are all competing. With just a quick few examples, obviously you can get very low latency by doing heavy quantization and sparsification to make things run on the edge, but that comes at the expense of accuracy. Similarly, you can get pretty low cost by doing very massive batching. You can, queue things together, pile them into a massive batch, run them on a TPU, and that ends up being cheaper per individual query, but you end up needing a queuing mechanism, so each individual API call takes longer. Whereas if you run each individual query on its own GPU in its own forward pass, very low latency, a lot of money because you need a separate GPU for every API request. So basically these three are all in competition. You can specify whether it's linear combination or a custom loss function, what your evaluation metrics are. This is the first thing. You can also specify with the drop-down list what frameworks, compiler infrastructure, cloud, and hardware targets you do or don't want to include in our search. And maybe you need to use AWS because you have your own credits, you have your whole infrastructure there. It doesn't matter to you what GCP can do. Maybe you need to run on a CPU for whatever reason, etc. So basically, within the search space of all of these configurations, with your own custom evaluation metrics, we will then crunch the numbers, spin up a load of jobs, benchmark your model with all these configurations, come back with a scatter graph or whatever format you want with the results, and you can then pick and choose your best. And we can show you the ordered list of the best based on your evaluation metrics, but you can still choose, actually, this one looks a bit better because of whatever.
But under the covers, Daniel, as you alluded to, basically, as a user of Ivy in this manner for deployment, I'm basically benefiting from the open source ecosystem, be it Triton, TVM. You guys are doing
Yes.
are kind of under the covers, giving me all of the benefits of these projects. So what about CUDA and
Well, yeah, well,
Rock
CUDA's one
M,
of
or what is it, that thing from AMD, Rock M? So
Rockham,
so
yeah.
yeah, so,
And also
so
AOL as well.
basically when I'm using Ivy, do I automatically benefit from all the developments in all these communities?
Exactly. That's the idea. And at the moment, our TensorRT backend is pretty well established, as is our XLA. We're working, it's a little bit earlier on our Triton backend, but yes, and with simple results on simple transformer networks, we've got results where we outperform the original frameworks in a lot of cases. So that the idea is that you benefit from all of these. It's not clear which is the best for particular setups. We see that sometimes XLA is way better. It's just 2 or 3 times faster sometimes than Torch or OpenAI Triton. Sometimes Triton is better, and it's not super intuitive when and why that is. And we want to elevate all of these tools so that they're all, let's say, at your fingertips as someone deploying, and we don't try to depend on each of these specific framework cross bindings to each of them. CUDA, for example, is one we support. We have a lot of raw CUDA kernels implementing our own Ivy API, also interspersed with TensorRT, which is, of course, NVIDIA's high-level. I say, of course, maybe not everybody follows the compiler space, but so TensorRT is a higher-level API by NVIDIA that also has all kinds of operator fusion and so on, which often is better than trying to do raw CUDA for everything. But exactly, all of these are elevated. And the other thing I would say is that we're also working with and hoping to also include other proprietary solutions into the mix, including Neural Magic with SparseML, etc., OctoML, etc. So yeah, it's early, but we also hope to bring proprietary solutions and show how good they are, as well as part of our search space, basically. But yeah, early on those fronts.
So we discussed this in an earlier conversation, but with the rise of foundation models, right? So maybe people will, I guess nowadays they call training the foundation model pre-training, right? So the big model is pre-trained on whatever public data or massive amounts of data, and then you've got fine-tuning or retrieval augmented generation. But clearly, people might do quite a bit of fine-tuning. So in the course of fine-tuning, I have a pre-trained model, I fine-tune it. So every time I fine-tune it, I will need to use IV before I deploy, right?
Not necessarily.
If the fine-tuning entailed changing some weights here and there in the model, right?
Yeah, exactly. So I see what you're saying. You're saying that if you deploy the model and then you fine-tune it more and you want to redeploy it, you would need to keep using IV.
Yeah.
Yeah, that is the idea. The idea is that basically we become the one-stop interface to do your deployment, and we can and the point here being that actually the landscape changes. So we've done some case studies. We'll be making blog posts about this soon, but if you take the last 12 months and you have one model that you're trying to deploy, with the release of Torch 2, with XLA being opened, with OpenXLA, with Triton getting more attention, with AMD releasing some really competitive hardware, the optimum solution for your model based on your static evaluation metrics, let's say the things you care about don't change, all that changes is the AI stack and it keeps evolving, it remains non-intuitive and non-obvious what the best solution is. And actually this changes every few weeks. So yes, you would continue to deploy using Ivy's autotuner, but actually other things apart from your fine-tuned weights, other things will change as well. So you can actually then continue to get speed increases by continuing to, let's say, have your finger on the pulse of this ever-changing landscape and always be the first to know when there's something better for your model.
So as a heavy user of these LLM APIs, and I'm sure a lot of our listeners are, I mean, the two major things you encounter right away are cost and latency, right?
Yeah.
So imagine, and it's clear one of the big trends in this space is a lot of companies will need custom models. So even inside a company, if you have a custom model and you have a lot of employees or customers hitting these models, you want your model deployment to be as efficient and cheap as possible, right?
Yeah, exactly. And that's what we look to provide. And of course, when for companies that are using or people that are using GPT-4, we can't directly improve their model right now, obviously, not unless OpenAI start using IV, fingers crossed at some point that they will. But until then, if you're using your model open source and you have access to source code, that's when we can really help and we can improve things for you. Yeah.
So the nice thing about this is in many ways you benefit from, because like I said, there's many different communities involved even in the deployment phase, right? So they all move in different speeds, right?
Yeah.
So if this community moves faster and
Yeah.
you benefit if you use IV, but if you bet completely on this other community B, and they're moving slower, then you won't reap those benefits. But if you use IV, basically whoever's moving faster, you automatically benefit, right?
Exactly. Yeah, you can also see this almost as a form of risk mitigation as well, minimization, because if you're using IV, you're not missing out, or you're not putting all of your eggs in one basket. Your eggs are split across each basket, and whatever takes off, there is a binding from IV, and you will have access to that cutting edge technology.
And so give us a sense of, on the deployment side of IV, give us a sense of some early design partners. You don't have to name names, but
sure.
What kinds of benefits or learnings or
sure
reactions have you gotten?
So there's the interesting thing, first of all, is I know that LLMs are the hot topic, but we're working with companies, working on cancer treatments, working on drug discovery, working on like improving manufacturing processes. There's still, despite the hype of LLMs, there are still a lot of companies doing conventional AI on a large scale that benefit from this as well. So the first thing is, it's not only people doing LLMs, the first thing. And it varies. So one thing is that, for example, some companies want to run, well, there's one company that wants to run all of their own models on CPUs because it ends up being much cheaper to run it on CPUs. They don't care about latency so much. They just need to get the results in a cost-effective way. They don't want to use GPT-4 because of proprietary data, and they use a mix of JAX and PyTorch and TensorFlow, actually, partly because a lot of the models are from DeepMind and so on. And they want to run on CPUs, and this is a problem. And actually, we are working on bindings to GGML, this really good bare bones C++ library to run heavily quantized models super efficiently, and being able to take the vanilla code that's kind of Python, PyTorch, JAX, and then convert it into really efficient quantized C++ is something that they're very interested in. That's one example. Another example is a company that's receiving, this is more LLM based, but they're receiving 1,000 queries, an hour or something, and wanting to get their cost down a lot because they're spending a lot. They have really low latency. They're running a separate GPU for each of these, and we're, early on, but able to get that down at least half with the very tip of the iceberg, and I think much lower when we get more widespread integrations. These are just two examples, but I guess to give an overall sentiment, the main thing is that it really depends on the hardware and the like, whether it's CPU, whether it's GPU, and it's not everybody doing LLMs. There's actually a lot of people that are, still doing computer vision, and we're working with a very broad range of applications, I suppose I would say.
Yeah. Come on, computer vision is everywhere, right? So, it's probably the most widely deployed deep learning model. I guess speech is right up there.
Yeah. I guess with the boom of ChatGPT, people maybe can forget that there's a whole still growing field of AI beyond that as well, and these are really important as well. But for sure, vision is huge.
Before we go to development, you mentioned C++ there, and I was just thinking, I don't know if you're familiar with this project llama.cpp.
Well, that's part of GGML, actually. It's from the same
So
creator.
it for our listeners, it basically took Meta's llama model and basically created a C++ inference code. So then you can deploy it on a variety of environments and settings. So I guess the question is, in principle, can you create llama.cpp using IV?
It's something we're working on. That's a real sharp edge question, and time will tell. We have somebody working on adding a GGML backend. GGML is the library that particular implementation was made in. There's now a company spun out from all of that as well.
Yeah, it's just one guy. It's just one guy.
Yeah, one genius.
And then
So yeah,
and
we're
then
working
it
on it.
inspired all sorts of other initiatives. I think there's a version in Rust even, right? So,
No, exactly.
yeah.
So obviously with all these things, right, there's always a trade-off between generalization and speed. Like for
Yeah.
any particular model and hardware, you can take shortcuts that general compiler infrastructure often can't. So if you have one model, making it purely in C++, probably getting that level is going to be a bit of a challenge for compiler infrastructure. But obviously Ivy and other compiler infrastructure looks to do is get close, but with a general solution that works with any custom model that you can think of, and gets very close to that kind of performance. So certainly something that we're trying.
All right. So now we go to part two, which is Ivy is going to accelerate my AI development with one line of code.
Yes.
So first, let's go back to the statement of the problem. So what is the problem as you see it in AI development?
Sure. So one of the problems is that while PyTorch has gained popularity, and it's especially in research and especially in LLMs, code is still fragmented across frameworks. Let's take one example. DeepMind continued to churn out a lot of state-of-the-art models. Those models are implemented in JAX and Haiku, and taking those off the shelf and training them in PyTorch is not possible. Now, of course, you can do reimplementations, but really the devil is very much in the detail. When it comes to reimplementations, often they don't quite get it right. The initialization scheme's wrong, tiny like default parameters on the the default values of certain activation layers or something, can cause the results to be very different because AI is quite a brittle process quite often to these parameters. So it's not trivial to reimplement them. Even if you do, it's very hard to falsify that it's totally correct. What Ivy enables you to do is with one line of code, guarantee an identical mathematical computation graph of the original code, but in your own framework and in your own version of your own framework, which can then be retrained, fine-tuned, and built upon to make new applications and conduct research. So this is the problem that, particularly for researchers, right? So for enterprises, they also do their own research, and this is really going to help research teams that are not just taking off the shelf stuff and building products, but are actually pushing the knowledge of AI forward by trying new architectures, trying new things. And for them, they do still have to wrestle with reimplementations. Even legacy code, like sometimes to get a paper accepted, there was a paper from 5 years ago implemented in TensorFlow. Your reviewer at NORIP says, I need you to compare to this on your data. This is often the case, and you can't do it. And it takes ages, and these, genius creative researchers are bogged down in tedious work that they needn't be. And Ivy unlocks them from that tedious work. I think that's one thing. And the other thing that just to quickly add to this, sorry, it's a long answer, but even in a world where PyTorch continues to, gain increasing like mind share and increasing usage in the deep learning space and research space, there is still a very long tail in numeric computation in general. And our view is that there are still, millions of people using scikit-learn and pandas and, even MATLAB used by millions of engineers who are using neural network toolboxes, etc. A lot of these technologies, which huge industries depend on, whether it's kind of boosting or XGBoost, etc., these then end up becoming more fragmented from the compiler infrastructure, such as XLA, OpenAI Triton, etc. It's all numeric computation on big matrices, often under the hood, and there's a lot of like shared tech that would benefit from being unified. So even though I would also say long tail applications matter to us as well. And if we can bring those, we can, bring them on board with all of the cutting edge technology, that's another big win, I think, because a lot of people benefit from that as well.
And given the current geopolitical situation, and given that the two centers of AI innovation are the US and China, and it seems like there's more and more usage of Chinese frameworks within China, specifically Paddle from Baidu and Mindspore from Huawei. There might also be papers written in this frameworks.
Exactly. And that's something we see quite a lot, especially, when you look at the top AI conferences, most of the top papers come from US universities and Chinese universities, and of course European universities as well. But China are a huge contributor to AI knowledge globally and research and so on. And yeah, exactly as you're saying, potentially partly accelerated from hardware trade restrictions and stuff as well a little bit. I know that Baidu and Huawei, I believe, give pretty generous credits to use their own hardware, etc. There's also Byron now as well. But anyway, I think this is accelerating usage of these frameworks in research institutions in China, and we support MindSpore and Paddle Paddle. So if you want to take a research paper that was implemented in one of these and bring it into PyTorch, for example, this is another big point. Yeah, exactly.
So, what is the proposed solution for in terms of this fragmentation? So, what is Ivy doing about this?
Yeah, well, how long do you have? I'll try to be concise.
Well, I think let's frame it in terms of a workflow where I read a paper
Sure.
in JAX, but my team uses TensorFlow, uses PyTorch.
Sure. So I won't, for now, I won't go into how it works. I'll just show how how the usage is like. So basically, with one line of code, you can pass in any function, model, or an entire library, and you call ivy.transpile. You pass this function, layer, model, library as the first argument. You put two TensorFlow, two JAX, and it's as simple as that. And back after the single line of code, you get it in your new framework, and it just works out of the box. So taking an example of a library, Cornea is a computer vision library written in PyTorch with hundreds of functions and I think probably hundreds of classes as well. With one line of code, Cornea equals ivy.transpile Cornea to TensorFlow. Now Cornea is a TensorFlow library, and you can use it as though it was always a TensorFlow library. This is effectively the user experience.
Our listeners might be thinking, can't I do that using ChatGPT or Bard? Hey, Bard or ChatGPT, here's some code written in JAX, converted to PyTorch.
Well, if they've tried it like we have, then they'll realize that unfortunately the AI isn't good enough for that yet, and it's quite a long way off, unfortunately. Having said that, we are now using AI to generate our code, actually. So in self-contained areas, our front-end functions, I won't make it too technical, but basically we have to recreate the APIs of all of these frameworks. Each of them have, hundreds or maybe thousands of functions that we need to recreate as a composition of Ivy functions. And I can explain why that's the case, but for now, it's just a big part of the engineering work that we need to do. We've tried out GPT-4 off the shelf. We're now using Llama 2. We've tried maybe 15 different versions, and we're able to recreate, after fine-tuning on all of our thousands of correctly implemented functions, we're able to get about a 35% success rate on re-implementing these functions after a few attempts, looking at the stack trace and re-attempting. And I think we can push that to be higher. But that's not off-the-shelf GPT-4. That gets, maybe 5% or less. It needs to be fine-tuned on our particular domain. So it's not off the shelf usable to do this kind of stuff, not really even close, but we are leveraging all of this technology to make our developers more productive in doing this. Yeah.
And I suspect the reason these LLMs don't do well is there's not a lot of data, right? So there's not a lot of, it's not like a language translation where you have the United Nations having so much training data, right?
Exactly. That they're also incredibly chaotic systems in so much as a tiny change leads to big different results. And there's also kind of one correct answer. With language, it's so subjective and so many synonyms.
Set temperature equal to 0, Daniel.
Yeah. Well, I think the point is, with language, there's lots of good answers to the same question. With coding, there isn't. There's one answer and everything else is wrong. And I think that's just a very different problem.
So this transpiler, as you described it, so give us a sense of status. So which combinations, which frameworks is it best at or most mature?
Sure. So in terms of, the frameworks it's most mature on are, so basically PyTorch is the one that we're putting most effort into, but it's actually not a question of maturity of the frameworks, because all of them, we have decent coverage in the front ends and the back ends. So the problem that we're facing right now, so it's not quite production ready. I think it's close, but there's a few sharp edges that we're wrestling against at the moment. One of them is transpiling classes, where we need to then start to analyze the AST. I won't get too technical, but there's a whole load of different ways of transpiling. You can either just do simple function tracing, where you have a static graph that you extract, PyTorch is a very dynamic language, so actually all of the Python code that you write can be part of the graph, including just if statements, for loops, and built-ins, etc., and iterators. So being able to extract all of that correctly and get it transpiled is a challenge, but we're getting good results. And then also getting the classes transpiled and so on is a challenge. So I'd say that the transpiler working really, really well, so it's a seamless experience, is probably a couple of months away. Speaking now, obviously in August 2023, by the end of the year, by September, October, I'm pretty sure it's going to be working well. But it's not really a framework maturity question. It's more like a transpiler, compiler, sharp edges that generalize question, really.
So the transpiler obviously also has early users and design partners. So
Yeah.
what are some stories that you can share? Well, again, without naming names. Yeah.
Again, with some reductions. So basically, well, one thread that probably stems across three large enterprises, or a few large enterprises, is that TensorFlow is still massively used. So there's a lot of huge engineering effort and huge infrastructure that's been built on top of TensorFlow for many years, and these companies are not going to suddenly throw all of this away for PyTorch.
By the way, that's all also validated by job postings.
Right. Yeah. Exactly. So there's a ton of people posting for TensorFlow jobs.
More than PyTorch, actually.
Yeah. So industry is still, and there's good reason for this as well. One of them is that PyTorch is taking steps, but TensorFlow is still much more mature when it comes to deployment. It supports more. I mean, MLIR was birthed in TensorFlow, XLA as well. Obviously now, Chris Lenton are going off and making modular, and Mojo, something very excited about. But TensorFlow have put more effort into making portable code that works across devices than other frameworks. So if you want to run on a mobile phone, TF Lite is much more mature than PyTorch Mobile, for example, and the deployment engine as well. So aside from the fact that it's more efficient as well, because it has a symbolic graph, and when you're not doing heavy dynamic code like LLMs, where you do need dynamism, the deployment efficiency of TensorFlow and JAX is objectively better than PyTorch in most cases. And of course, when you're a company, this matters a lot. So one of the common stories is companies that are using TensorFlow that want to keep using it because it's faster, but they want to have a bridge to the PyTorch research that's exploding, and they want to be able to try these state-of-the-art models but not throw away their entire stack. So we are that bridge for such companies. This is one. And another one is those companies not only want, well, it's kind of the same thing twice, but not only state-of-the-art models, but the libraries. That the PyTorch ecosystem is very strong, so they can then bring these libraries into their stack as well. There are some companies as well where it's about having PyTorch and bringing JAX code in from DeepMind, etc., because there's a lot of amazing Alpha Star, etc., and Alpha Fold and stuff that people want to use, and bring those in. That's another one. I think as far as big enterprise users go, it's this first one though. For researchers, it's different again. I mean, there's a load of researchers that still use TensorFlow because they did Andrew Ng's course. A lot of them have learned on TensorFlow, and there's a lot of researchers picking up TensorFlow as their first framework. But even PyTorch researchers still have to often compare to legacy code, and the vast majority of legacy ML code is still in TensorFlow because it was the front runner for many, many years. So this is another one as well.
I forgot to ask you.
I would say,
I forgot to ask you this question when we were in the deployment side, which is, you have some initiative involving Hugging Face models, right?
Yes. So, well, basically, at the moment, we're doing a lot of our benchmarking on Hugging Face models. When we release, we'll hopefully have some good results to show that a lot of the Hugging Face models can be executed more efficiently than using PyTorch by default. So, because this is the world's model hub, like I think we can quite safely say that, and a lot of the state-of-the-art models and the reference models that people compare against and use in companies are from there. So it's an obvious place to pull from and benchmark against. So yeah, these are some of the models that we're working on as our reference models, and yeah, more to come on that when we release when we finally get around to launching at some point soon, hopefully.
So the idea there is if I go to Hugging Face, I identify a model and I decide, you know what, we're going to use this a lot, and then you folks will provide me the tools in order to deploy it much more efficiently.
Exactly. And it's not because of any special binding to Hugging Face or anything. It's because obviously this generalizes the framework. So in the same way that you would get benefits from a model you built yourself, it also applies to Hugging Face. But these models are a very good reference to kind of benchmark against, especially. Yeah.
So Ivy, in closing, Ivy is an open source project. So how can people contribute?
Great question. The first thing will be to join our Discord. So again, if you go to our website at unify.ai, and right at the top, there's a Discord link. So that's a good place to start. At the bottom of our website, for those wanting to apply, you can apply to do a full-time role, an internship. We also have perhaps unusually, we have a contributor role that you can apply to. And when you do, and if you meet the bar, and actually it's also very competitive, but if you meet the bar, you actually can be brought into our team, join all of our internal meetings, get directed mentorship, and actually work on some internal tasks on our private Trello board as well. So there's kind of another tier to getting involved if you want to, but it requires an application process. But otherwise, join the Discord, go onto our docs, check out the contributing guide. I don't know the URL, but if you just go on, unify.ai, click on docs, click on contributing, there's a whole guide and set of YouTube videos explaining the process. We now have 1,200 contributors of code to the project. So we have these very deliberate, low-hanging fruit open tasks, of which there are hundreds open. And, there's many more to come once those are done. So because of Ivy's modular design, there is always something to do that's a nice entry-level task to get you involved. And we're very responsive on the pull requests. So yeah, there's a very, very easy route to get involved lightly via that path. Yeah.
So here you can name drop some companies if you want, but who are some of the companies who have been using Ivy or even contributing to Ivy?
Oh, I might withhold from name dropping until we've got anything concrete, but certainly, I mean,
but let's just say some leading AI teams.
Exactly, some leading AI teams are using Ivy. I don't want to drop anyone's name in it yet until talking to them. But if you look through our stargazers, you can see, for example, you can see kind of that certainly people from all of the top companies are getting involved and using this in their own personal things, using it in some early prototypes and stuff. So we've got good early feedback. That this is providing value, and more to come when we fully get it out there in our full launch in a few weeks.
And with that, thank you, Daniel. And again, reminder, you can meet Daniel and Ivy at the AI conference, September 26 to 27. Go to aiconference.com. And as far as Ivy, go to unify.ai.
Thank you so much.